examples. Example 1 says, given this chart that represents a function, so t is all the inputs, and g of t is all the outputs. So if you want to think of it as x values inputs, outputs, y values. Evaluate g of -2. So the input is -2, which means we go to the t value of -2 right here, and we're supposed to find basically what the output is. G of -2 evaluates to what? We're just going to go ahead and pull out the 7. So G of -2 is 7. If we were thinking of that as an ordered pair, it would really be -2, 7. Part B says the same thing. The input is 0. So we're going to go to the input or the domain value of 0, and G of 0 spits out what? G of 0 spits out a 3. So the output value is 3. And again, if I was thinking of that as ordered pairs, it would really be 0 for the input, 3 for the output. Part C asks something a little bit different. It says find t so that G of t is 9. So it's already giving you the output. Question is, what is the input? Again, the output is already given. We're supposed to go find what the input is. So we're going to go to the output value of 9, which is right here, and we have to see what the corresponding input value is, and it looks like that's going to be a 3. So, whoops, t must be -3 actually. So the t value -3 gives you an output of +9. Part D, same type of question, find t so that G of t is equal to 1. So we go to the output 1, and what is the input for that? That's going to be t equals 1 as well. So ordered pairs for these guys would be -3 input, 9 output, 1 output, and 1 input as well. Example 2 says, given this function p of x equals 2x squared plus x minus 1, evaluate p of 1. So again, we're given the input, and we're supposed to find the output. So the input is x. We're going to go place it in all the x values upstairs in the function, and that's going to give us 2 plus 1 minus 1, an output value of 2. So if the input is 1 for this function, the output is 2. So we're given the input, and we're supposed to go find the output. We plug in the -2 in all the x locations. Plug in -2, and we do order of operations with the exponent first. That's 2 times 4, plus a -2 minus 1. That's 8 minus a 2 minus 1, which is 6 minus 1, which is 5. So the output we got is 5. That gives us the ordered pair -2, 5. The problem asks to evaluate these two pieces. So the first one evaluates to a 2, and the second one evaluates to a 5. In a graph this time. Part A says evaluate f of -2. So again, the input is -2, and now we have to go to the graph and pull out the output. So the input, or the x value, is -2. So I'm going to go to the x value of -2, which happens to be right here. If I stand there to get to the graph, I go up, and that ordered pair is -2, 1, it looks like. So the output that I'm going to pull out is 1. At -2x coordinate, the y coordinate, or the f of -2 value, is 1. Same thing for part B. It says evaluate f of 3. So the input is 3, which means go to the x value of 3. So I'm going to walk over to the x value of 3 right here. And if I walk over there, here is what my graph goes through. The x coordinate 3 and the y coordinate is 2, it looks like. So I have to get the output of 2 and put it there. Input 3, output 2. Part C says find x such that f of x is equal to 1. This is a little bit different. The output is already given to us. Again, I'm supposed to find what the input is. So I'm interested in the x value. Let's go get rid of these guys. So we're going to go to the output of 1. So the y value has to be 1. Here are the y values 1. If I just look across those y values of 1, make a horizontal line through this y value of 1, my graph goes through the y value of 1 here and also here. So there are two places where my graph goes through the y value of 1. This one is -2, 1. So if the y value is 1, the x value is -2. There's one place. And I also have another place where the y value is 1. I'm going to have to approximate that. So right there, I don't know, like maybe 2.2 or something. We're just going to approximate it. So it looks like 2.2. 1 is also an ordered pair that goes through my graph, or my graph goes through that ordered pair. So the other x value would be x equals maybe 2.2. And again, all we did was sort of guess what the x value might be there. Part E, or Part D says, find the domain of f. So let's go clean everything up. And domain, remember, means x values, or the horizontal axis, what values it covers. So I'm going to walk left to right and see what the first value is that I pick up and what the last value is. The first value right here, and the last value, there is none because this guy keeps going to the right, so I keep going forever and ever. If I do this in set notation, it'll be x such that x is in between some values, but on the right, since I know that x goes on to the right forever and ever and covers all positive values to the right to infinity, I'm just going to say x has to be greater or equal to some number here on the left. And again, I'm sort of going to guess and say that's negative 2.5, let's say. So -2, oh actually I'm totally off, scratch that. -2 is right here, we got -3, and then -4, so maybe like -3.5. And again, I'm sort of estimating. On your homework, probably you won't have to estimate, and it'll make it go through coordinates that are easier to read. So x is greater than or equal to -3.5 is all the x values that this graph covers. Find the range of f. Those are all the y values, or the values that the vertical axis covers. So we're going to say all y such that, and then figure out what's going on with the y values. So we're going to start at the bottom and go all the way up and see where it starts and stops. And again, as we go to the top, we know that the y's go up forever and ever and ever, so they never stop and go all the way to infinity. But at the bottom, looks like the y values kind of start right here, which is -3 on up. So the y values are all the y values that start at the bottom at -3 and go all the way up and up forever. So y greater or equal to -3 would be the range of this function.